Hi, this is Jose Luis, and this guy that we have here is also Jose Luis, actually. And welcome to a new video on this series, Introduction to Parametric Modeling. In this video, I would like to do a quick hands-on exercise that is going to be about mesh manipulation. So I'm going to teach you how to take a mesh and then deconstruct the vertices, the normals, whatever, and use that information to mess up with the mesh a little bit. Like, for example, I implemented a very simple attraction repulsion rule that takes point in 3D space and uses that point to deform the mesh and to bulge it to basically repel the vertices of that mesh and create like a version of the mesh that has like all those deformations. And actually, the result of that exploration ended up being something like this collection of creepy versions of myself with an exploded face, with an imploded head inside of the shoulders, or this guy who looks like he had a really, really rough day. Correct? But yeah, this exercise is perhaps less focused. It doesn't have a clear goal. It's more about taking the mesh and seeing what can we do or what kind of modifications can we implement weird uh, to find weird manipulations of the mesh using algorithmic logic. So if you're interested in that, just let's just get started. Let's get hands-on right now. Okay, this exercise is going to be, if you will, it's going to be less focused and a bit more exploratory, if you will, than previous exercises, just because I'm not sure that I have a clear agenda with this one. I sort of want to explore things out. So, for example, the way I would like this exercise to work is that I'm going to start with some mesh and that I will import into Grasshopper. And then what I would like to do is I would like to explore how I can make modifications to that mesh that are based on certain rules. So for example, if I know that a mesh has faces, that it has vertices, and that it has vertex normals, something like that, then very simple, straightforward modifications to this mesh could be, for example, taking each one of those vertices, moving it in a direction that is going to be perpendicular to itself, so along the normal of the vertex, and then reconstructing a new mesh that has the same connectivity, it has the same faces, but the only thing is that the vertices are in a different location. So that could be one way, and it could be, in a way of just scaling the thing up or down in a way that is not based on a reference point, but is based on the perpendicularity of the mesh. We're going to, depending on the geometry of the mesh, we may get like weird intersections and undercuts, but obviously that's a different topic. Now, the idea here is that I will want to explore what possibilities I have, just because I don't want to just, for example, maybe scale this in an homogeneous way. Maybe what I want to do is I want to take the vectors and I want to modify them in a way that some of the normals become larger and some of the normals become smaller. And therefore, when I recreate the mesh has a different scaling, a different offset in certain areas of the mesh. And that can give me some kind of like bulging effect or some kind of deformation that could be interesting or not. I actually don't know. So I'm just going to roll and see where, and start playing with the mesh and see where we get. And then whenever we find an interesting outcome, we will take that one, we will bake it, and that will be the result of our exploration, for example. So this is a very common thing in design as well. Just starting, see what we can do and see if we find anything interesting in the process. So let's just do that. Let's go back to Grasshopper and start seeing what can we do with the mesh that I'm going to be loading. So back in Rhino and Grasshopper, I have imported this mesh that I have here. Can you recognize this mesh? If I look at this, or if I look at this way, this is a 3D scan that my brother did of my head like a couple years ago, and the original scan has like millions of vertices, so I downsampled it to be around 1,000 or something. That is which is a pretty lightweight. mesh, if you will. And I have brought this into Rhino, and I'm going to go here to geometry. I'm going to go to mesh, and then I'm going to drop this mesh here, and I'm going to set this one mesh here. Okay, and then just for the sake of it, the first thing that I'm going to do is I'm going to deconstruct the mesh so that I have access to all the vertices, the faces, the vertex colors, and the normals. And I'm going to check a couple things out. The first thing that I would like to check is, for example, what is display? I would like to check the points. So for example, I would like to check how are they sorted, just because it's a good thing to get a sense of these things. So for example, oh, that's a lot. So I'm going to check that it has, I'm going to check that the mesh has 1,000 faces and a few less vertices. And if I crank the numbers up, you can see that I'm going to hide this, okay? Oh, that's even worse. And yeah, I can see that the vertices are pretty much all over the place. There's no clear order to the vertices. So that's not probably going to be a good way to work with a mesh, right? But that is also normal because, I mean, which order are you going to find in my head, right? My head definitely doesn't have any much order, not inside, not outside, nothing. But jokes apart, when when in the previous video when I was talking about the sphere is a very clear primitive, so it's very easy to find order in the sequence of the vertices. But for nature inspired meshes or for things that are coming from complex modeling processes, then those logics typically get lost or they're just not existent, basically. So those are the vertices. I would also like to take a look at the faces. And if I look real quick over the faces, I can probably see that all of them are triangular faces, which is kind of the norm. Having quad faces is typically strange, and actually some modeling environments don't allow that, and they automatically subdivide the quads into faces, into triangular faces for you. I can see that the mesh has no vertex colors. We're not going to play with that in this exercise. I think I'm going to do that in the next one. And then I have normals, which I will also want to display. So I'm going to display the normals in here, and you can see that the normals kind of make sense. These normals are sticking down, are pointing down, and the normals in my ears are kind of all over the place, but the normals on my face are also kind of making sense and over my head. So I think this is looking good so far. So I think we are ready now to start maybe messing a little bit with the mesh and see what can we do. I think the first thing that I would like to do is to create some kind of, for example, I'm not going to work with the mesh yet. I'm going to create a cloud of lines that are going to be sticking out of the face of the head. So I'm going to create a collection of lines like hair, for example, that is going to be sticking out. And we could also, I mean, we could even, yeah. So I'm going to create like lines that are going to stick out of the mesh. How can I do that? So, well, I already have a collection of vertices that are on the mesh. So this could be the starting points of a collection of lines. So for example, I'm going to drop here a line component, and this could be all the starting points. The endpoints, though, should be points that are somewhere outside of the mesh. So what I can do is, because I do have all these normals, what I could do is I could create a new collection of points that are moved away from the mesh in the direction of the perpendicular at control distance. So for example, I'm going to move all these points, all these vertices, right? And for example, I could move them in the Z direction. And then if you do that, then you can see that I'm getting like this kind of perpendicular sort of hair, which is very strange, right? That's not what I want. If I can do perpendicular, right, and then what I will get is all these lines that are protruding out of my head, correct? But also, this is parametric design, so I would like to control the length of all these lines. So obviously what I'm going to do now is I'm going to take all these normals and I'm going to set the amplitude of these vertices to be a particular value. So which is going to be some kind of slider. And then I'm going to plug that in, and now with that I can control how far these lines are sticking. And you can see that when they're short, they kind of are a fairly good representation of where there's density on the mesh, and also the indication of the orientation of the mesh, which is kind of nice, right? And if I were to bake this, for example, I would get like a super interesting, I don't know, is this interesting? I don't even know if it's interesting, but it looks like a ghostly representation of a presence that is not there anymore, or something. I'm not sure about that. Now, obviously, this is a little boring. Well, it's not boring, but it could be more exciting if we were to able to come up with a rule, some kind of rule, to decide families of lines to be larger or to be smaller. So I wonder how can we do that? Well, one technique that we have seen in the past in these videos that we could use is attraction and repulsion. Or in other words, just creating a point, measuring the distance of that point to all the other points, and using some factor of that distance to drive the length of these vertices. So we could try that out. We could say, I'm going to create a point and I'm going to put that point somewhere here near my head. I'm actually going to stick it, I'm going to put that inside of my brain here, right at the center of my head, correct? And then what I'm going to do is I'm going to calculate, I'm going to bring that into grasshopper. So I'm going to create an empty point. I'm going to set it here. And then I'm going to calculate the distance from that point to all the other points, and those are going to be the vertices. So I'm going to go to vector, point, I'm going to go to distance, and then I'm going to calculate the distance between all the vertices of the mesh and this point. If I were to set that distance right away as the length of the vectors, you could see that something strange happens. Well, not strange, it's actually what it should happen, which is that the lines close to my head are shorter because the distance is smaller, but the lines that are farther away, so at the base of my head, for example, are much larger. Okay, so that's one thing. But we know that sometimes doing this doesn't really yield good results. A rule that we have used in the past, which is I find more interesting, is using the inverse distance. So for example, if I say that what I want to do is use 1 divided by x, so if I do that, then we have an inverse relationship where points that are closer are much larger, and you can see how the lines on my head are getting much larger there, and whereas the ones that are farther away are smaller, right? And if I want to have a bit more control of this, what I can do is I can control it by a factor, and saying that what I want to do is divide one number by, instead of 1, which is a fixed number, I want to divide a factor that I can control by that distance. And there, whenever I make that larger or smaller, then that changes. And then you can see that as I move this now, as I put it inside of my body, now my body is bigger, and now my head is kind of exploding backwards, which is kind of interesting. Right? Okay. That was one way to go about it, for example. So what shall we do next? Since the geometry of my head has a very particular orientation, right? There's the head, and there's a very clear z-axis, which is where the head is growing, whatever. I kind of want to explore what this idea of attraction repulsion, how it can work on the mesh if we only explore this attraction or repulsion, or in other words, the distance to the attractor point, if we only explore it in the C direction. All right. So, for example, what I would like to do is I would like to perhaps create a line that is that defines where we are across how high we are on the mesh, and then, for example, we can find a point along that line. And what I would like to do is I would like to do the same thing, attraction repulsion, but in this case, I'm only going to take into consideration the difference in height. So it's not going to be the perfect linear distance to each one of the points, but how far away in the C direction from this control point is going to be. And therefore, once I have that, I can use that information to bulge the whole area on that height and to reduce the other one. So, because it will create a slightly different effect. Let me show you how I would try to do that. Now, back in Grasshopper, what I could do is I could create that line, right? But as you have seen in previous videos, and if you know me already, I would like to do something a little more parametric than just a line, you know? So, and also it's a good thing if I teach you perhaps like something new. So something that I can do is, if I have my mesh, what I can do is I can create a bounding box around the mesh to figure out what is the line that fits perfectly this head here. So for example, what I can do is I can go to primitive surfaces bounding box, and I can take the bounding box of this mesh, correct? And then I can decompose the box corners to get the 8 vertices of this box, as you know. And then what I would like to do is I would like to create a line between this point and this point. Since I don't really know what those points are, what I'm going to do is I'm going to highlight this one, and then you can see that it's green, so this is the one that I want. B is this one, that's not. C is this one, D is the one in the back, and E is going to be this one. So now I know that the line that I want goes from A to E, correct? And if I hide the box and the vertices, you can now see that I have a line that is perfectly fitted to the mesh that I'm trying to work with. And then if I evaluate that curve, I'm going to do analysis, evaluate curve, and if I evaluate that curve at a parameter that goes from 0 to 1, because it's a straight line, and I know that the domain will start at 0 and will end at 1. If I don't know if that's for sure, I can always reparameterize the curve, and that will ensure that the range, the domain of the curve, it goes from 0 to 1. But anyway, I have 0, I have 1, so I have a point that can now travel between these two ends. And once we have that, what I can do is I can now I can decompose, what I want to do is I want to find the difference in the C height for each one of them, correct? So what I want to do is I would like to decompose each one of the vertices. I'm going to deconstruct this point to find the C height. So that's going to be that C height here. But I'm also going to deconstruct all the other vertices of the mesh. I'm going to take the vertices of the mesh and I'm going to deconstruct them to get the C heights here. And then I'm going with an expression that is going to be, for example, the C of the vertices. This is going to be the C of the attractor, right? What I'm going to do is, this is the C heights of the vertices, the C height of the attractor. And if I do the C height of the attractor minus the C height of the vertices, then I'm going to get something like this. Okay, I'm going to get all these values, but hold on. I'm also getting negative values. I am getting negative values because some of the points are below the attractor. So, because I will not want to work with negative values in this case, because I want all the vertices to be moved away from, well, let's not get into that quite yet, okay? And so if I do this, and if I now create, for example, if I now take all of this and I use, for example, this expression to define the amplitude of the vectors that I'm going to use to move my, so I'm going to take the normals and I'm going to set them to this amplitude, and then I'm going to take all the vertices and I'm going to move them by this much. So you can see that now the vertices on the bottom are moving a lot and the ones on the top are moving very little. And then if I now, if I now create lines between all the original vertices and the ones that I have moved, you can see that what's happening is that the lines on the bottom and are sticking out a lot because the difference is really large, whereas the lines on the top are actually moving inwards. So, and if I go up, you can see how like the head is kind of contracting, and how the yes, so something like that. Okay, and at this point, this mesh representation, or this representation that I am seeing here with the lines, is actually not being clear enough. So I think that at this point I'm done with lines, and what I would like to do is I would like to show you how, instead of creating lines, what I would like to do is I would like to use these two techniques to affect the shape of the mesh, to make it larger or smaller based on this logic. The way we're going to do that is going to be super simple. Just like before, I deconstructed the mesh into vertices, faces, colors and normals, etc., etc. What I can do is I can also construct meshes if I have all that information. Again, same as we could construct and deconstruct points, construct and deconstruct planes, construct and deconstruct vertices, we can construct meshes if we have all the raw information, which is going to be basically where the vertices are and how they are connected with faces. So if I drop this here, you can see that it's asking me for the vertices. So I have them here, right? It's asking me for the connectivity of the faces. So I also have this from the original mesh. And you see how it's not asking me for normals? Because normals can be computed given the geometry of the faces and the vertices. So I don't need to feed that in. And I have just constructed a mesh that was exactly the same as the original one because I took the exact same information. However, if what I want to do is I want to create a mesh that has this logic, the logic of the points that have been displaced, then the only thing that I need to do is, instead of using the original vertices, what I need to do is I need to use the new collection of vertices that I have used to move, that I have moved away from the surface. So if I plug this thing in now, you can see that what I get is this very strange distorted mesh. Can you see that? And actually you can also see how some of these faces have kind of exploded out, and you can see how I look like an alien now here. So can I bake this and check it out? Woohoo! So yeah, I have exploded in a very strange way. Okay, I think that might be because some of the vertices are not perfectly welded. Is that correct? Let me see if that is true. So I'm going to turn this off. I'm going to show the original mesh now, and I'm going to go to mesh, repair, and I'm going to, what is mesh edit? So weld selected vertices. So okay, so let me go here and mesh weld. And then the angle tolerance is going to be 0. And then if I look at the mesh now, do I have less stuff? I still have, let me do this again. So let me mesh, edit to weld selected vertices. I'm going to select everything and I'm going to be done. and the mesh is, wow, have you seen that? The mesh is now, remember how it was 900 vertices? The mesh is now 500. And if I look at here, I can see that it's probably not exploded anymore because all the vertices are welded. And I can do it, and now you can see that I have really messed up my head. All right, and I can keep, so I can keep this in underneath. So, and where did the point that was here go? Yes, so if I now move this, you can see how like my head is protruding out, or if I now bring it closer to the body, you can see how I get like a bulky kind of me in a way, you know? So if I bake this, for example, now I'm going to create another version of me where the head is kind of similar, but the body is a little larger. What about if I mess up with my face? Where is my face? My face is here. So I'm going to put this on my nose, literally. But I'm getting like really, really strange results. Like that. Let's bake that one and see what. Whoa! Well, someone got a beating. Okay, that is not very cool. All right. So not cool. So how about we reconstruct the other one? So what I'm going to do is I'm going to construct mesh, and I'm going to use the other one that was with the meshes that I moved and with the faces that I have the original connectivity. And what I can see now is that, wow, that's kind of something. So if I do this, then my head basically blows up. If I move a little bit like this, my head kind of stays where it is. Let me see. So let's do 0, for example. Okay, so that's going to be 1. I'm going to bake this, and this is a very strange mesh that I have right there. So now I'm going to do 0.5. I'm going to, then my head is going to be, my head kind of imploded. Whoa, and my head reversed inwards. Can you see that? How it went like inwards? And what if I do 1? 1 is basically going to make things even worse. So I'm going to bake this, and this is going to go here and here. And you can see how my head is now like shoved inside of my shoulders, which is also kind of interesting. So yeah, it looks like apparently the attraction repulsion exercise with the point gives a few more interesting results, I guess, even though I still want to play with this a little because, for example, if instead of going inward and upwards and outwards, I were to say, for example, that this has to be the absolute value so that I don't have negative values, then no head is going to implode into itself, no part of the mesh. So if I do that, and so for 1 it's not going to make a difference, but for 0.5, for example, could you see how before we did the absolute value, it looks something like this? But now the negative part, instead of imploding, it now explodes out as well. So I'm going to bake this, and I'm going to move it in here. Wow, this is a very strange Jose, right? Ugh, it's kind of creepy. All right. And maybe I can factor this. So what if I added a factor to make sure that things don't go too much out of control? And then the factor is going to be, for example, something that could be smaller. And then this is going to be factor times, and so that I can work with that and like just control it a little so that it's not just way too much, you know? So maybe something like this could lead to some exploration. You see, oh, that one is interesting. So look at this one. This one is like the same, but instead of like a really large number, it gives me this, this is kind of interesting. Look, at my face is pretty faithful here and the rest, and it just looks like I have bulged my brain, so I look like an alien kind of thing. You know, this one is kind of interesting. So I think I'm going to keep these two here. All right, so how was that for a collection of messed up houses, huh? Oh my God, that was bad. Okay. Uh, yeah, so this is what we got. So yeah, I think this is where I would like to leave the exercise. I think it's been creepy enough. I'm not sure which one would I 3D print or make a mall out of. Maybe this one can be interesting. I'm not sure, but it's also a little creepy, I have to say. Especially if we do this and then we can see like someone's had a really rough day here. Especially this guy. This guy has had a really rough day. Anyway, so I think I would like to leave it here. This was an exercise where we learned how to mess with meshes and deform them and reconstruct them. And hopefully we also learn how to do a little bit of design exploration, maybe. So how to try different things out and see how they work and do some mathematical relationships to improve, for example, something that was not really working well to induce a much better result just by changing one function. Okay, which I think was pretty interesting. So I think I'm going to leave it here, and but I'm going to do more recordings and more exercises on meshes. So see you on the next videos. Thank you very much for watching this. Maybe consider liking this video, subscribing to the channel, turning on notifications, etc., etc. Thank you very much. See you on the next video.